isolated because there are certain forces holding matter, that particular matter together. And that force is no other force than the interaction, that is, the behavior, the relationship between electrons of different atoms of energy. So what it means is before this became a compound, it means this element came together. And this element coming together, it means that the atoms of this element were involved in chemical process, in a chemical reaction, joining one atom to the other, chemically. Sharing of electrons, that's just the base language. Sharing of electron. Electron is the base to the forces we're talking about, because no force can exist in a matter without the sharing or the the aspect of electrons coming into play. So this example of compound. When I said a compound can be splitted, in this view, we're saying that this is sodium chloride. It can be splitted because there is an electro or an ionic bond or an electrovalent bond. We also review some of the different types of bonds or bonds that exist in compounds or molecules. So what we're saying here is, if I have sodium and a chlorine bonded together, what I'm saying is this bond can be splitted. Yes, because now this informs the idea of what we'll be discussing next, which is the chemical reaction. Yes, it informs the idea because chemical reactions exist between atoms and compounds, or between elements, atoms of elements and compounds, anyhow you want to put it. All I'm saying is reactions, chemical reactions, are informed by the sharing of electrons between elements and between, yes, elements. And this transformation has to do with transformation between reactants, which is one or two reactants, that results to a new substance, which is usually called a product. And so this transformation cannot proceed without the breakage and the formation of bonds. So you can see that the bond, the idea behind bond, is what we refer to the electron, the sharing, the behavior of electrons to form, forces that hold this matter together. That this is an existence. That you and I can say, okay, I want to, take water. It's because water wouldn't have been in existence if the forces were not holding the individual elements together. So this can be splitted, yes, and in splitting, we can talk about different possible ways of splitting. It is informed by the behavior of the atoms, because in the periodic table we said atoms exist and elements exist, and they can exist as electropositive or electronegative um, uh, elements. And we say electronegativity is the relative tendency for an atom or an element per se to attract electrons to itself during or in a uh, chemical reaction or in a compound. What I mean by chemical reaction in a compound is, in this atom is electro. This is a very good example. This is an electronegative atom. This is an electropositive atom. So with these, the charge cloud, what I mean by the charge cloud is that the electrons involved in bonding in this compound spend more time with the chlorine, which informs the partial negative and the partial positive. That is, when we move further to discuss dipole. And I think for now, just allow me to explain this by saying all of this bond here, because we said this bond here, each bond is made up of two electrons. That is the bond here, made up of two electrons that came together to form a single bond. So what we're saying is that this element is electronegative, highly electronegative. So what happens is most of the electrons involved in the bonding spend most of the time floating due to the electronegativity. This is why we said there's a relative tendency for an element to attract electrons to itself. So you can see it has an attraction, it has a pulling effect on this sodium, and this is due to its electronegativity. And also for the aspect of sodium due to its electropositivity. The reason behind all of this is that every atom is trying to strike what we call stability, trying to be stable. And so in any way, if there's a cleavage, there's a breakage, there's a splitting resulting to maybe certain chemical processes, you realize that the electrons involved in the bonding are all transferred to this atom. So in chemistry, when you see a full arrow, it depicts that all the electrons involved in the bonding are with this atom. So if in any way this cleavage, this breaks, what you have is you have sodium and chlorine. Now this informs the idea that being negatively charged has allowed it to attain its octet state, because in its atomic shell it no longer contains 7 electrons, but rather 8 electrons in its atomic shell, giving it the octet state, the octet rule, observing octet stability. So most of combinations, most of the reasons or the basic reasons why atoms, elements come together is to track stability, because they are always trying to be stable. We don't want anything that messes with the stability. And that is why sodium can freely give out this electron, because in its atomic shell as a cation, it has, rather the stable electrons it needs for its stability. So it's ready, it can give out this one other electron without stressing. So we'll stress on this point, but all I'm trying to explain here is that really a compound can be splitted, and it's splitted into this and this. This kind of splitting is informed by the heterolytic cleavage. Hetero means the atoms or elements involved in this compound are elements of different kinds. You can see chlorine atoms are different from sodium atoms. Sodium element is different from chlorine as an element. So you see that the elements involved in this compound are two different. So whenever you have electrolytic cleavage, it's informed by which of this atom is most electronegative. So the most electronegative takes the whole of the electrons involved in the bonding due to its relative tendency. So another example is if I have, let's say, a molecule like this, I have this, if this should cleavage, what you have is, okay, I think rather I would prefer it to be this way. So what happens is if there's a cleavage here, there's a breakage of this bond due to a chemical process. This atom shares the electron equally. This element, this compound split, and the element shares the electrons involved in the bonding equally. So you have hydrogen radical plus this radical. So this type of splitting is homolytic. Why this is informed by what? By heterolytic cleavage. So this is the idea of saying a compound can be splitted. So either a compound can be splitted by ordinary chemical process, or a compound can combine chemically. The combination chemically is the sharing of electrons. That is, this electron that was shared equally here, that was splitted and was shared equally here and here unequal, can come back. It's just like the definition of a compound. When it comes to splitting, it's just like undoing what has been done. So when you say it can combine chemically, that is, it involves electrons to form bond that holds the compound together to form a compound, or a compound also can be seen as to be splitted into different forms by a chemical process. So that's a compound. And then finally, a chemical reaction. So what do we understand by a chemical reaction? I am just taking this. I'm just taking this for an elementary stage. We are trying to understand some of the terminologies and then have a lighter view about them. Gradually, in the course, we'll be discussing extensively what this whole content is about, with examples and with, a lot of other useful information that inform this content. So, a chemical reaction. A chemical reaction. A chemical reaction. What is a chemical reaction? We said a chemical reaction is the transformation. Yes, is the transformation of, is a process of transformation. Yes, the process of transformation that includes the transformation of reactants to products, that is, reactants to new substances. And this is informed due to the breaking and the forming of bonds. So no idea of chemical reaction thrives without having to understand that chemical reactions are built around breakage and formation of bonds. So chemical reactions can only be understood based on breakage of bonds and then formation of new bonds. So let me pick one example to just give us a preview on what a chemical reaction is. Let's take, for instance, I have this reaction. Okay, here I have this reaction. Okay, now this is what we call the reactant. Okay, so whatever it is here is the product that is formed as a result of this reaction. So this whole concept and idea is what we refer to as a chemical reaction. And the aspect of breakage of bond we spoke on is, you remember earlier on when we said sodium and chlorine, when it dissociates, you have plus, minus. We talked about that in the aspect of electrolytic cleavage earlier on. And then if I have water, this is water. If this water molecule ionizes, you have what? If it ionizes, you have H plus, you have plus OH minus. So if you look at this, there's a breakage of bond first. Then before you can see the formation of bonds here. Before the formation of bonds. So you can see the attraction between one of the reactants to the other is based on the charge. You see the electric positive going to this, but I'll explain further when it comes to the initiation of reaction, is that these atoms are rich in electrons, these ions are rich in electrons, so they initiate the reaction. They are nucleophiles, they are electron-rich species. So what we mean by electron-rich species, they are nucleus, they are species of, could be ions, could be neutral molecules that have electrons, because electrons is the reason why the bond forces exist. So an atom an ion, a molecule per se, can be rich with electrons, and what it is interested in from the name nucleophile is that they are nucleus lovers. And what is found in the nucleus is the proton. You see. So you can see this attraction between the negative. Most of them appears to be negatively charged. Some of the species we said about the nucleophiles are negatively charged. So they love the nucleus. In the nucleus is the proton. So they are nucleus lovers. Philic means lover, nucleus lovers, nucleophilic. So what they are looking for is they have enough electrons and they're ready to look for this positive man here, which is the proton. And these are called electrophiles because they are electron lovers. This man has the electrons. So you can see that the relationship between atoms is more or less a relationship of electrons. You know, okay, you have the electron. I want to come to you. If we can bond together and gain stability as a compound. The compound exists because it is stable. Okay, yes, it is stable. But at the cost of this in different approaches, different applications of chemistry, you realize that there are sequence, there are mechanisms of certain reactions that have actually proceeded before the major product is formed. But those compounds that were formed are mostly called intermediate. They could not survive to exist to what it is as product because they are not stable. So stability is what all the elements and atoms strive to gain. So let's not divert from the basic concept. What we're saying is there's an attraction between these two and these two. Why is it a separate view? I use this to explain more better because these are from one of the reactants. So if there's a breakage of bond in one of the reactants, definitely the reactant which is electronegative will want to pick on the reactant, the other reactant which is what? Electropositive. So this is why it informs this. So, but in writing of chemical formula, you find out that let me just clean this. I still have some of the cost content, so I can use the space. So, looking at this, I want to write this out from chemical formula. Yeah, this is plus one charge, which is Cl minus 1, which is the valence also. You can either use the valence or the oxidation state for combination. We'll talk about that when we come to talk on law of combination. You know, when we concentrate on how to write chemical formulas, chemical equations, and all of that. So you can use either the oxidation state or the valence electrons to combine atoms together chemically. So this is 1, 1. So interchanges, you have Na1, Cl1. This is minus 1, this is plus 1. So you omit the sign. You omit the sign, the same thing as NCl. This is the new product that's formed as a result of. Oh, sorry. This shouldn't be Cl. This should be OH minus 1. This should be OH. Yes. So that the product you form is OH. So this is how this new product is formed as a result of this sodium to this. So you see there's a new product formed. Initially, first of all, there was a breakage of this bond. That's why I brought this example. The breakage of this bond. The breakage is as a result of this dissociation here. The bond breaks, and we spoke about what type of bond breaking, which we said is electrolytic here. So it breaks and it informs this ion here. So furthermore, this also breaks and informs this ion here. This picks this and gives us a new product, sodium hydroxide. And the same thing goes to this and this. So you have hydrogen plus 1, you have chlorine minus 1. So you have H minus 1, Cl plus 1. So you omit the sign. These are some of the rules we use in writing chemical formula. So you need the sign, you end up having HCl. So what we're saying is that the product here becomes what? The product here becomes something new, new substances of what? Of this and this. So you have sodium hydroxide plus HCl. Okay, we'll talk about this because the states also are very important in chemical reaction. We'll do that when we get to chemical equations. Talk about the state of each, why it's very important. So this is a preview of what a chemical reaction is. A chemical reaction has to do with the transformation of reactants into products. And this transformation is achieved due to the breakage of bonds and the formation of new bonds. So this is um, some of the preliminaries of what informs general chemistry. We'll be talking about a lot more others subsequently. So I want you to hit the subscribe button and subscribe to this channel and wait for more videos to come because we have a lot of them, a lot of, you know, a lot of writing to do together. So I hope to see you in the next video. Benedict. Thank you.